Welcome everyone to the B.I.R.D.S midterm demo. To begin with, we're going to run through a whole system check of how it will work in the wild. So to begin with, we have to check whether we see a bird to start even the process. So let's go ahead and look at a bird with the image recognition software. So we see a bird, the door's open, so it's waiting for the laser beam to be broken. So that means that something dropped. Let's go ahead and drop. So the laser path is broken, so we're looking for a cigarette. In the cigarette camera, we find a cigarette, then we reward the food, and then we store the trash that was inputted, and then we close the doors back up. And we go back to the look for bird loop. In this scenario, we can run through the whole system check, but instead of detecting a cigarette, we're going to input something that's not a cigarette. It should just time out and then close back to the find loop, the find bird loop. So let's go detect the bird. We see a bird, the door's open, and now we're waiting for the laser brake to break. So it broke the laser plane, and now we activated the trash camera, but we're not detecting a cigarette, so it should just time out. So that means that we discarded it. That should go out of the system, out of the housing, and we reset. In this scenario, we're going to run through the whole system, but we're not going to break the laser plane. That means a bird was landed, but it did not deposit anything. So let's go and detect the bird. We see the bird, the door is open. In a second, there we go. The doors are open, but we're not breaking the laser plate. So should just close the doors. There you go. Here we have what we're going to think the bird system is going to look up. Once it's finished, we're going to have a cutout here for the birds to input stuff from there. We're going to have a cutout for the food to come out when we don't want it, or the trash, the disposable trash. And we're going to have, this is going to be removable, so for maintenance, you're going to be able to remove it. Or you're going to have direct access to components for maintenance. And we also have a feature over here, if you want to look up through the back. We have designed each platform to have a little cutout hole so we can put a securing, stuff that will block these guys in place without permanently applying glue or something. We can also put all the cable management in the back so it's going to look cleaner. And that's about it. We also have the capacitor plate that we still have to figure out how we're going to support, but it's going to be something like that on the outside.
Here we have our indentation platform with the door mechanism attached. As you can see, we have two separate servos that are connected to two separate rods that are connected to two doors. These doors act as flappers to open up when a bird flies up to the birds and close back up after a bird leaves some sort of object into the birds. As you can see, they work in tandem, opening and closing together to fully close and not allow birds access to any of the platforms below. Here we have our laser grid system within the birds. This laser grid system will detect if the bird drops an object into the housing. As you can see here, we have our laser bouncing back and forth between these two mirrors into the photodiode. If the laser plane breaks, we'll see this LED turn on down here. For example, if I break the plane, the LED will turn on for a couple seconds and then turn off to reset. So if the bird were to bring an object, say a leaf, and drop it in, we will see the LED turn on. And we will continue to get consistent values, maybe with a couple of mistakes, but per our engineering specifications, we said that we wanted the laser plane system to read a dropped object about 80 to 90% of the time. So with a couple of drops through the laser plane system, we see that that 80 to 90% success rate is accurate for our system. Here we have our trash analysis platform. When the birds bring an object to the birds, they will drop an object and it will fall past the laser plane system into our trash analysis chamber. Here you can see we have a servo connected to a rod, which the rod is connected to a platform that will flip the object one way or the other. The two directions will be dependent upon if they drop trash, namely a cigarette butt, or if they drop some other object that is not trash. If it is not trash, it will discard outside of the birds, back out into the environment. If it is trash, it will discard into our trash chamber beneath. Here we have our food dispenser platform. On our platform, we have connected a stepper motor with a food container, and within this food container, connected to the stepper motor, is a screw that will screw food out underneath the food platform to a tubing system that will feed the birds. As you can see, we can drop in a little piece that the stepper motor will spin the screw and continually move some object within this food container out the hole and into the bird's mouth. Here we have our trash container for the storage of the trash that the birds drop into the housing unit. When the trash drops in here, this will be a removable container when all of these platforms are connected. Into these two holes will be two L brackets with a securing rod going through the shell and the L brackets. When the rod is removed, this trash storage can be removed completely, dumped into a trash can, and put back into the birds with ease.
So here we have the image detection for the bird. We're meeting our specification here to be within 2 seconds. As you can see, we're getting about 10 frames per second. We have a lot of extra objects that we're detecting, but the only thing we're really caring about is the bird. So as we can see on the screen here, we get a confidence of generally over 90% on the bird. All the other flashing doesn't matter because all we're caring about is the bird. And even as I kind of move this around, we can see that we're still detecting the bird. If I spin it around, we're still seeing the bird over 90% of the time, meeting our specification as needed. Here we have our custom cigarette detection model that I trained using Edge Impulse. Over here we have it running on my phone as a webcam going through Edge Impulse. We've got some objects under here, some things that a bird might discard. And as you can see here, we're detecting the two cigarettes. Because this needs to be trained on a specific environment, sometimes some things right now will enter and it'll classify it as a cigarette for a little bit, but sometimes it'll stabilize and it won't be a cigarette, so it just needs to be fixed a little bit. But for the most part, we can classify cigarettes up over 90% of the time, meeting our goal for our engineering requirement.
Here we have our system fully functional and being powered by our own custom PCB power supply. This is taking a 9-volt, 2-amp wall adapter, and we're stepping it down to 5 volts to power both our custom main PCB board and our Jetson image processor. And we have full functionality, they're compatible, and we have tested this and there have not been any fails, any crashes. It's all good.